Our next problem is to calculate the number of moles of 4 grams of sodium hydroxide, which is NaOH. First of all, we can notice that there are 3 sig figs here. There's 3 sig digs, depending on how you want to do it, but 3 important numbers, and so we're going to use that when we get further through our calculations. I'd also like, though, to talk about where they're getting this symbol from, NaOH. We know sodium is on the periodic table. It has a symbol of Na. So if we come over to the periodic table here, we see that it's right here. Na is sodium. Now this is group 1A, and all elements in group 1A have 1 valence electron, which means 1 electron in its outermost shell. All atoms want to be like the noble gases, to say it in very layman's terms, which means that they want 8 valence electrons. We'll do VE for short. For sodium to become like one of the noble gases, it would be easiest for it to lose that 1 valence electron rather than gaining 7 more. So that's what it would do. Since an electron is negative, if we are losing a negative, it's like doing minus a negative, that's doing a positive. So we have Na with a 1 plus charge. Let's go back here. The second part of this is hydroxide. Now if we look at our periodic table again, we don't see hydroxide anywhere on here. It's not an element. What it is a polyatomic ion, which is a group of 1 or 2 or more elements that work together with 1 overall charge. Now before we get too far, let's remind ourselves what the charge of sodium is. It's a 1 plus. And hydroxide is a polyatomic you will want to memorize. It's OH, hydroxide, H and O, and the charge for that is a 1 negative. So if we look at how these would bond, this one will give up its 1 electron to this group, and this one group becomes a negative charge because it's taken that 1 electron. We often call this the Crisscross Rule, which means if we put the charges down there and down there, we get the symbol for our molecule. We wouldn't write the pluses or negatives because we know that it has to equal out that way. And whenever we have 2 of the exact same numbers, or if we just have a 1 in general, we don't have to write that, so we just have an NaOH, which is where we got that symbol right there. Now we can get to the meat of this problem, and we start with the fact that we have 4 grams. That's our given. It's always good to know what our given is and what we want. So given we have 4.00 grams, and we want the number of moles. So question mark moles. To get to that, we first need to know what the molar mass, and that's what we figured out in the last problem, but not of sodium hydroxide, but it's the same process. So if I have 1 sodium, 1 oxygen, and 1 hydrogen, I can look at my periodic table to figure out what the mass of each of these are. If you watched the last podcast, you noticed that our sig figs were greater here than they are on most of our periodic tables. Sodium we would call 22.99 if we rounded it. And that would be, that would be grams per mole. Oxygen, hopefully you're starting to memorize this one already. We use it so much, it's easy to memorize. And it's easier when we get to the correct number of sig figs. It just becomes 16.00. Again, grams per mole. Then we have the hydrogen, also another good one to just memorize because we use it so much. 1.01 grams per mole. Now we don't have to multiply by anything in this one because it's all 1 to 1 to 1 ratio, but we just have to add it all together. When we add that all together, we get 40 but we want to make sure that we have the correct number of sig figs. If you remember, when we do sig figs in addition, we do the same number of sig figs after the decimal as the lowest number decimal. Each of these have 2, which makes it really easy for us. It's 40.00 grams per mole. Now, if you're reading in the book or trying to take some shortcuts, you would know that moles is also given with an N, and we know the mass, this would be a little m, and this molar mass would be a big M, and we could do N is equal to the mass that we have over the molar mass. And that's again what the book does. However, I want to get us used to the fact that we're going to be doing stoichiometry quite a bit in this course. So what we always want to do is say, what do we have as our given, and that goes first. So we have 4.00 grams of NaOH as our given. Different teachers set this up in different ways. Generally, I like to do the multiplication sign so I remember what I'm doing, and a fraction sign. Since this is on top and I know I don't want grams of NaOH, I'm going to have to put grams of NaOH on the bottom. I get that from this molar mass here. So I put 40.00 grams of NaOH. Well, that was also involved with my moles of NaOH. That would be 1 mole of NaOH. That would go on top. Now my grams of NaOH, the unit is gone, the number's not, don't get confused there, but the units are gone, and I'm left with moles of NaOH, which is what I wanted. So I'm getting the right thing. You will see it's the same thing here. Whatever's on top is divided by whatever's on the bottom. Same thing here. This is on top, that's on the bottom. I would multiply 4.00 by the 1 that's on top, that's just 4.00, and divide by the 40.00. Again, this process, I know it looks long here, it is for what we're doing, but it's going to get us used to what we're going to be doing when we get to stoichiometry. So if I calculate, and hopefully you can see this without actually having to use a calculator, 4 divided by 40 is just 0.100. And the reason I have 3 numbers after the decimal is because when I deal with multiplication or division, we look at the value that has the lowest number of sig figs, which was this 4.00 that we started with. This one had 4 sig figs, and this is just a counting number. 1 mole is a counting number, so that does not factor into our decision about sig figs. So we would have 0.100 moles of NaOH. That would be our final answer. At this point, either way of doing it, just remembering that calculation and plugging it in and getting that answer would be fine. Starting to set it up the way that we're used to setting it up would be excellent because you're getting used to that, but not completely necessary at this point. I did mention that some teachers do this in a different way. Some teachers will even call it the train method. And we start the same way. We have 4.00 grams of NaOH. And they'll just do fraction bars. And 1 mole of NaOH on the top with the 40 grams of NaOH on the bottom. Equal signs, and our answer would go here. Now either way is fine. Again, any 3 of these methods are fine. I just want to show you different ways that different teachers do go about it. It's the exact same mathematically. Again, this is the process that we will be using as we go more and more into stoichiometry.